So next we will talk about how we can analyze the packet dumps that we have captured. So for that, we use packet analyzers. Packet analyzers can be both in the form of hardware devices that you can plug in into your network to probe the network, or they can also be in the form of software such as Wireshark. So these packet analyzers, they mainly work in layer 2 or layer 3 of the OSI model, which is your data link layer as well as the network layer. So you can see all the packets, their destinations, their source, and what type of protocol they are using. So when looking into a network dump, what are the important things that you need to like examine or you need to observe? So the first is DNS, which is domain name service. So every time you visit a website, for example, if I want to go to say youtube.com and I type youtube.com in the browser doesn't know what youtube.com is, because the networks, they don't work on names, they work on IP addresses. So first I would have to translate the name of the website, say youtube.com, into an IP address of the actual server that is running that website. So for that, like my computer will send a DNS query to the DNS server, whichever server I'm using, and then in return, I will get the IP address for the youtube.com. So every time you are like, examining a network traffic, for example, there is a suspect that say like, was involved in pirating the movies on torrent, then we can capture its network traffic and see if there is any DNS query with say www.torrent.com or whatever type of torrent website they were using. So we can look into DNS messages and see like what type of websites the user tried to visit or the user tried to log into. The next are the URLs. So most of the time you will see the actual like complete URLs in the packets that are transferred as well. So when we do the workshop demo, you can see that it is very clear like what are the URLs that are being used. Next are TCP streams. So all the TCP communication works in the form of stream. So once you establish the TCP connection after the three-way handshake, all the messages that are sent from client to server and from server to client, they all become part of one TCP stream. So if you want to like, from, for example, if there are thousands of messages in your packet capture or the, network capture that you have like collected, and you want to follow the communication between a specific client and a specific server, all you need to do is find the first message, TCP message that was sent from client to server or server to client, and then you can just follow that TCP stream and you will see all the messages that have been communicated or that have been sent by the client or the server. Next are the objects. So a lot of the time, for example, whenever you go on a website, you see there are a lot of images on the website, like some JavaScript code is over there as well. You can see, like some GIFs or some video links as well, or hyperlinks. All those things, when you go, for example, if I type youtube.com, all those images or thumbnails, or you can say the pictures that are there in the YouTube's main interface, all of that data or all of those objects have to be downloaded on my own machine. So if I just follow or examine the network TCP stream or the communication between a client and server, I can extract these objects, images, videos, they can be files as well, out from that network stream. So this property of extracting objects is very handful or very useful when it comes to doing the analysis of network traffic. So for example, if client A or person A sends a file to person B over the network, you can extract the entire file out of the packet captures if you are able to capture the whole communication. Next, we can also look into traffic patterns as well. So, like these are mainly for intrusion detection purposes or say, firewall purposes. So we can see that, in normal or benign cases, a person X logs into the websites yz.com two times in a day, right? But if the person is logging or, using the websites on a particular day, say 5 times or 6 times, that would mean that there is a deviation from the normal behavior. So we can do this type of analysis as well, where we can analyze the normal behavior and then try to find out the differences or the changes to that normal behavior. All right, so next a question might come in your mind that what type of information we are looking for in each case. So that would depend on the actual nature of the case. So for example, depending on the case, if we are talking about SYN flood, so what is SYN flood? SYN flood is a specific type of network attack. So in which the attacker leaves the TCP three-way handshake in between. So in order to perform a complete TCP connection, you have to do a three-way handshake, like client sends a message, SYN message, then the server responds with an acknowledgement, and then the third message client sends again with a which we call SYN ACK. So what can happen is like each server has limited number of connections that it can establish with clients. So attackers can just have uncooked or not fully cooked connections. They can just send messages to the server, and then server will be in that state where it has like a lot of incomplete connections with a lot of computers from the attacker. Next, and so in this particular case, what we are looking for is the SYN messages in the network dump. So we can filter out all the TCP SYN messages and see that from where these messages are coming from. We can see their IP addresses, and for like future reference, first of all, we can look into the IP addresses, that who's the owner of those IP addresses, as well as we can also give them to intrusion detection system or like our firewalls. So in future, if that attack happens again, or any message from those IPs come again, the firewall will be able to block that. Next, denial of service. So similar to SYN flooding attack, denial of service is where you overwhelm a server. For example, like a server is capable of hosting 100 or 1000 users, and all of a sudden, like there are 5000 users that are like trying to access that server. So in that case, the server will become overwhelmed and it will not work, and it will stop working. So in case of denial of service attacks as well, we can look into the incoming messages IP addresses and see from where they are coming. Next, for example, in cases of illegal material. So for example, somebody is like, accused of watching or say distributing child porn. So in this case, we will have to verify that, whether this person or the accused person actually visited the, restricted website or not. So for example, if the like the child porn is distributed on a website, say www.xyz.com, then we will have to make sure or like look into the network traffic and first figure out whether this user actually went to this website or not. So how we can do that? We can look into DNS messages. So if there is a DNS like message DNS query for xyz.com sent by the user, then that means the user tried to visit that website, and that could be the start of our case. Lastly, malwares as well. So malwares, and this also is true for all the other type of file transfers that you do from client to server, that once we have the network traffic, we can look into the TCP streams, or we can look into the network streams and try to extract the malware. So in case of malware, sometime if the malware is strong and it burns out your computer, there is no other evidence apart from the network traffic. So what we want to do in that case is extract the malware from the network traffic and then try to run it in a enclosed or in a safe environment where it doesn't infect other PCs, and try to dissect it or reverse engineer the malware and see how it's working and how we can prevent these type of malwares in future. So let me quick give you guys like a demo of Wireshark before we proceed. All right. So this is like one of the packet captures that I found on the internet. And in this packet capture, like we can see different techniques or different things that we just discussed. So the first is like, we can see that at the very top, so this person or whoever was the user that generated this packet capture wanted to like visit this website, www.packetpioneer.com. So you can see that there is a like message DNS query sent from this IP address, which in this case is the address of the user 192.168.1.107. And this is the IP address of like the destination IP is the IP of DNS server. And you can see that this user has requested the IP address or DNS translation for www.packetpioneer.com. So if we find any message, DNS message for any website from a server, or like from a client machine, that would indicate that the client wanted to visit that website. And you can see that DNS server responds with the names of the servers and IP address of the server as well, that is hosting www.packetpioneer.com. So once the client or the user in this case receives these IPs, so you can see there are two servers. This is the first one, 98.129.229.28. And this is the second one. So the user can select any of these two. The user selected the one starting with 92. Then the user tried to establish a TCP connection. So you can see this three-way TCP handshake here as well, that the client sent the send message, the server responds with a send ACK, and then client sends an acknowledgement. So for like send flooding attacks that I was just mentioning earlier, if after just sending the send message and receiving the send ACK, you don't send acknowledgement message, that means that this TCP connection is not fully cooked or is like incomplete. And in that case, the server will be, like in hanging state. So server will request or will be looking for acknowledgement message from you. So if you stop communication after, like receiving send ACK, then you can overwhelm the server, send 1000 send messages, and the server will think that it is communicating with 1000 different clients. Moving forward, so once the TCP connection is established, then we can see that the client send the HTTP message get. So what are these two get messages? So you can see there are two HTTP get messages. This is the first get message in which the client is requesting a JavaScript file. So you can see that as well, jQuery.cycle.lite.min.js. So and this is the second resource that the client requested. Let me see here, which is an image. So it is, available at this particular address, home directory, images folder, and then this image, Packet Pioneer logo, green, blue, white. So these two resources were requested by the client's, say, web browser. And then you can see that all of this is sent over the TCP in the form like of different packets. Similarly, for this image as well, you can see there are a lot of other TCP messages exchanged between the client and server, in which this image Pioneer image was sent from the server to the client. So what we can do is, let me show you guys here. You can just right click over any of these. So once I have this TCP connection, the first TCP message, I can right click over it. And then to follow this, I can go to follow and then follow TCP stream. So when I follow TCP stream, you can see that all the messages that were exchanged between the client and server from that point onward. So right after following or establishing the TCP connection, the client sends this get message. So you can see all the details as well. So the client sent the HTTP get message, the host, this is the name of the host. You can also see the web browser that this client was using. So he was using Mozilla Firefox, and it was running a Windows PC. So you can see all that information. And then this is the response from the server. And then this is the whole file that was sent by the server, which is uh, the JavaScript file. Then the client sends another message, get message, starting from this point onwards, which is for the image. And then you can see the OK response from the server. And then this whole data right here, it represents the .png file or the image file. So you can either just copy paste, this data, store it in the form of a PNG file and extract it. There is another way to extract the objects as well. So you can just select, or let me show you. Go to file, and then you can see an option of export objects. So export objects give you different options like FTP data. So if there was a file that was transferred over as FTP, you could extract that. Similarly, it gives you an option to extract all the HTTP based objects that are transferred over HTTP. So if you look back here, we have two objects that were transferred over HTTP. The first one is the JavaScript file, and the second one is the image. So if we select HTTP here, Wireshark will automatically extract or carve out that object, those objects for you. And you can see that it has extracted two objects. The first is the JavaScript file. You can save this file if you want. So for example, I just saved this file in the form of JavaScript file. I will show you guys later. And you can see the image as well. So for image, it also gives you a preview option. So you can save the image if you want. or you can also preview. So if we select at preview, this is the logo. Let me show you that I received, or that the Wireshark was able to extract. All right. So this is the logo that the Wireshark has extracted. So in this way, like if the client is accused of, say, watching child pornography, you can extract those images from the network traffic and verify whether the claim is right or wrong or not. All right. And let me show you, this is the JavaScript file. So you can just save this file as .jv, and you can see like the whole JavaScript code that was there on that website. So this way, like, no matter what type of data is transferred, if it is an image, a text file, a JavaScript file, any other type of file, you can extract that, including malwares, viruses, trojans, all of them you can extract from the network traffic. All right. So next we have a case study where Mr. X is a suspect in child pornography case, and he attempted to erase all of the evidence by formatting his computer. So he just formatted his computer, and like once he format, you will lose all the RAM data, you will lose all the data on the hard drive. So there is no other evidence, on his computer. Luckily for the law enforcement agencies, Mr. X's roommate was running Wireshark at that time when Mr. X was doing the illegal activity, and police got hold of that Wireshark capture. And now we want to investigate the high dust, and we want to investigate whether Mr. X was actually like watching or selling or distributing child pornography or not. So how would we solve that? First, we will look into the DNS messages. So if there is a DNS query sent from Mr. X computer with the name or the complete address of the website that has child pornography, for example, xyz.com. So just as I showed you guys in that the previous network capture, if there is a DNS message going from Mr. X computer with the name of the alleged website, that would mean that Mr. X tried to access that website or tried to visit that website. Next, we can use TCP streams to reconstruct the whole session. So as I showed you guys, you can either just follow the TCP stream and extract the data yourself, or you can just use the Wireshark's, functions of automatically extracting the objects, and you can see, all the images that were there on that particular website. Similarly, we can look into URLs as well. So in the communication, you will see a lot of URLs that are used. For example, in this case, you can see like right here, starting from, okay, I have to cancel this stream. So you can see all these URLs in the website. So if the, like the communication is not encrypted, you will be able to see all this data in the plain text. All right. So these are like a couple of things that you can do when you are doing forensic analysis of network traffic. You can look into what type of websites the user might have opened. You can look into, what type of messages were exchanged between the client and server or between the two entities, and you can extract all the different type of data that might have been transferred. This could be image files, this could be like video files, it could be documents, it could be other type of files as well. So the last topic is honeypots. So we will talk briefly about honeypots, what they are and what is the purpose of them and why they are useful. So all the things that we have discussed so far, we just, waited for the attackers to attack the system. And then, we would have like, logs in the, say, intrusion detection systems or at the firewalls. But this is not like a preferred way that, like you just wait for the attackers to attack your system and then you analyze it. What, like, because the attackers, they are continuously working and developing newer malwares, newer viruses that we don't have any defense or any previous signature, so we cannot easily identify and block them. So in order to get this threat intelligence, there is a technique in cybersecurity which is called honeypots. So honeypot is a security mechanism that creates a decoy system or a network to attract the cyber attacks. So what you do is that instead of exposing, your entire system, you just create a small decoy, or you can, for example, if I'm the administrator of GVSU, rather than putting the whole GVSU network on, at risk, what I can do is I can just put one or two PCs on the internet without any security protection and just run some basic services on those PCs. So to the attackers, that will be like, a sweet spot, or you can say a honeypot, and they will be attracted to those PCs or those devices. Then they would, like, technically speaking, whatever malwares or viruses they have, they will try to download them or infect these honeypot PCs or honeypot system that I have created. And in this way, I will be able to collect all the malware and viruses that the attacker might have developed. And then, without any security issues or without the risk of escalating the attack, I can just contain the attackers in one specific honeypot and then collect all the information about their capabilities. The benefits are threat intelligence. So just as I mentioned, we want to know what are the capabilities of the attackers, and the best way to do it is to just give them a honeypot or give them a small bait and then expect them to download or infect it with the viruses. Another thing is distraction as well. So if you have like a very critical system, you can have like you can deploy all the major security infrastructure on that critical system and then have a small honeypot as well in your network. So what will happen is when the attackers are looking to attack your network, they will be more tempted, or you can say more inclined towards attacking the system with less security. So they will automatically will be shifting their focus on the honeypot. So in this way, you will be able to divert the attackers from your main system. Another advantage is the early warning. So as the attackers are attacking the honeypot, you will get to know that there is some person or some organization that is trying to attack your infrastructure. So it can also serve as early warning, and you can speed up, or you can say improve your security mechanism on your main assets or your main resources. Lastly, it can be used for educational purposes as well. So all the communication that the honeypot does with the attacker, you can capture that. You can see what type of malwares, what type of tools the attacker is capable of using, and then you can prepare your defenses according to those things that you learn from the communication of attacker and honeypot. So this is it for this lecture. If you guys have any question, let me know by email and I will be happy to help.